Should we as Christians trust the science? And what does this even mean? Does this even make any sense? Let's find out in this episode of According to Sci-Faith. I'm Josua Göcking, and you're listening to the podcast of Sci-Faith. Should Christians trust the science? This is the question the title of this podcast episode asks, and of course it's a loaded question. It's a question which you heard a lot, especially during the time of this pandemic, but also in other times you repeatedly hear this trust the science or trust what science says. And the question is, what does it really mean? Should we as Christians trust the science? What does it mean to trust the science? Or does this statement make any sense at all? And for this to understand this, we need to first understand what science actually is. So the word science comes from the Latin and means as much as knowledge. So what science actually is the process of acquiring knowledge. So man, since its beginning, wanted to find out more about himself, about the world he's living in. There are these questions that people have asked for centuries: who am I, where am I from, and so on. And to find an answer to this, they started something like science, where they found out new things about the world and wanted to explain them or wanted to understand them. And science has evolved in different ways throughout the centuries, and the modern science started basically in the 17th century with Newton and many others. And what makes the modern science so different from the previous methods of approaching science was that it put a high emphasis on the experiment. And this made it very, very effective, because if you had a wrong conclusion about something scientific, you could immediately test it in the experiment and you would know, okay, this was the wrong approach. While earlier times, you had wrong conclusions which held themselves for a long time because they weren't put up to a test. For example, there was the Ptolemaic worldview from the Greek Ptolemaios, who had this view of the Earth in the center of the universe and the sun and the planets revolving around the Earth. But since nobody did an experiment to test this until Galileo did, this worldview was held a long time by the people. So the modern way of doing science, by putting a high emphasis on experiment and stating that every claim or every observation and conclusion from this observation has to be checked by experiment, and all the statistical analysis that go into that, have brought science a long way and made something which we often call the scientific revolution. As it was a real revolution that it started, and that led to new discoveries being made every about 20 years or even less since the 1700s, which is a remarkable thing. But how does this really work? So I think everyone knows it basically from school, how it used to be explained. You make an observation, you kind of try to explain this observation, and then you make a statement about nature, and then you try to confirm this statement by doing experiment or first doing predictions that the statement would result in, and then doing experiments to prove your statement. This is basically how science works. But what also is of big importance, if you look into the history of science, is to do not believe in what previous generations have thought, or challenge beliefs that have been stated before, or scientific statements that have been stated before. So there was this great physicist, Richard Feynman, who was probably one of the greatest physicists of the last century after Einstein, and he stated it in this way. He said, "Science is the belief in the ignorance of experts." So he said, science is basically distrusting what experts are saying, and saying something else and trying to prove it or trying to make a case for it. And this is how science progresses. And actually, if you look into the history of science, that's many times how it went. For example, Isaac Newton, who is basically the father of modern science, thought light to be consisting of particles, which he called corpuscles. But what he thought them to be was particles. But more and more people came to believe, or especially one person, Huygens, I think was his name, he believed that light wasn't a particle but a wave. And because Newton was the expert on this, many for a long time did not believe what Huygens said. I think Newton himself did put a lot of doubt on his theories, so he kind of fought him on this, and but in the end they could show that light has an interference pattern, and this pattern can only be explained if light is indeed a wave. If you look at it later with upcoming quantum mechanics, you see both were kind of right, but still it serves as an example that for science to progress, it needed somebody who wasn't known, who was not a big figure, to have distrust in what the leading experts, in this case Newton, were saying, in order to make science progress. And this is always, or oftentimes, how science goes forward, how we acquire new knowledge, because we start by usually tend to go to a place where we think we know it all, and then somebody needs to distrust what we held to believe before, to make advances in science, to find new things out. So this is usually the way science works. So the statement of Feynman, that science is the belief in the ignorance of experts, is absolutely right. And what this says to our statements, if we should trust the science, it basically makes this statement nonsensical, because science itself, to progress, needs distrust in the scientific statements made today. So I need to specify this a little bit, because there can be a confusion. Because what you need to understand is science has basically two representations, or two manifestations. So there's one part which is the data. So I said the modern science puts a lot of emphasis on the experiment, which is good, and which is has allowed it to progress that fast and that magnificently. So there are experiments, and the results of these experiments are usually called data. And then there is the interpretation of this data. So you can have a lot of data, but you can interpret it in different ways. And the more data you have, the more statistics you have, the more ways to interpret the data there is. As an easy example, you think of a coordinate system, and in this you have drawn some points somewhere randomly in there. And you can either say, okay, you want to find a law behind these points. And you can either say, for example, okay, maybe they follow a straight line. Maybe if I put a straight line through these points such that every point is kind of near to this line, then maybe this describes the data. But maybe some other person says, okay, there is like a curve in there. Maybe it's a parabola, or maybe it's a sine function, or depending on how the points in the graph are put, this could all be possible. And even if you have a function which describes the data really, really well, where it is such that every point is on the line of the function you have chosen, it could still be the wrong function because you could over describe the data, because data is not without error. So every data point usually has a systematic and a statistical error, which is just coming from complications in measuring, where there's an error on every measurement. And if you have something which perfectly describes the points, you should be also doubtful, because probably you are also describing statistical errors in your function, which is not what you want, because you want to describe the underlying law. You don't want to describe the statistical and systematical errors which are in the data. You want to put that out. So there is this this way of where you have the data and you have the interpretation of the data. And even in the data, as I just mentioned, there are errors. There are systematic and statistical errors which are in every measurement contained. So even in the data, you need to be careful. Even there, you cannot just blindly trust what the data says, because there's also a bias in the data. Okay, in the hard sciences, you might say, okay, what bias can there be? It's just science. And you're probably right, but also there is bias occurring. But for example, in the humanities, this can become a real problem, where you can say, okay, which sample sizes they used for their polls, which people they asked, how did they ask the questions, and so on, which can change the result that you receive, but which is actually just an error in the results. So a statistical or systematical error, but not the true statement. So in German, we have this saying that you say, don't trust a study you did not fake yourself. And there's some truth to that. So if you have a study where your own biases are put into the study, then the result will change depending on which bias you have. So this needs to be considered if you are considering scientific data. And there's also like how you need to check how accurate, how rigorously the study was done. So this is also very important. But then more than that, the interpretation, it's even more vague. There you need to be even more careful, because the interpretation also depends on a personal bias. So, and this is one statement that I make in my book, which right now, unfortunately, only is available in German. But there I do this differentiation between the scientific data and the interpretation. And I say, even if all the data can hints to something is true, the interpretation of this might still not be true. I use the example of evolution and say that all the data hinting to evolution might perfectly be true, and I myself believe that most of these data is completely accurate, because there have been many scientists working on this, and many scientists from different beliefs also. So I tend to believe that this data is true, but by no means that this actually mean that the interpretation of this data needs to be accurate also. So there could be a completely different interpretation of the data, which would still describe all these scientific data, but still a completely different interpretation. And this is what one also needs to consider in science. So there's on the one hand the data, which also needs to considered with reasonable doubt. And on the other hand, there's the interpretation, which needs to be considered with even more doubt, because the interpretation can be biased highly. And so especially if the science is pretty new, or if there's a new topic on which we are gathering science, there are many of these things occurring where the data is misinterpreted, or where you have too few data to actually say something fundamental, and where then the data maybe gets misinterpreted, where new data comes about which changes the view on things. And so there you need to also always be careful and be kind of doubtful about the results, or maybe more skeptic. So in my book, I also have a section about skepticism and doubt, where I differentiate those two. And I think what science clearly tells us is to be skeptical in a scientific way, but not doubtful in a way where we just doubt scientific results that are clearly proven, or not proven, but where clear evidence is available. So what to come back to my point, there is an importance to be skeptic about data, which is the scientific way to do things. So and this is especially true if there are new things coming up, like new viruses, new things that we didn't know something about before, and the data is coming in live. Because if you might have noticed, most of the science we are talking about today, if we are talking about Newton and his mechanics, if we are talking about quantum mechanics even, the science behind this has been done hundreds of years ago. The quantum mechanics was, the theory is relatively new, but it was stated in the 20s of the last century. So it's almost 100 years old by now. So this is science where a lot of time has passed and a lot of experiments have been done to again and again confirm this theory. But if there's something new coming up where we have live data coming in, then it's something completely different, because anytime there could be new data hinting at new things that we didn't knew about before. So there's, especially in such a instance, a high importance of being skeptic in a scientific way. So if we are in such a situation as we are now, so what shall we do? What is to do? And I think from a scientific point, it's really important to discern the data, to look at which data we can trust, which is really data that has been acquired in a trustworthy way, in a way which is rigorous, in a way which is accurate, and which data we cannot try. This is oftentimes much harder than it seems, and usually it needs a lot of scientific experience to do that. So if you now say, I'm not a scientist, I'm not educated in this area, what do I do? And I think for us Christians, there is one point which helps us out. So first, I would say, I think I'm not a scientist also is not a really good excuse. I think we should all be kind of educated in all these areas, and it's today pretty easy to become educated enough on such a topic. But even farther than that, we as Christians have this gift which can help us in especially such a way very much. This is what the Bible calls the gift of discernment, or the gift of discerning the spirits. And you can read about this, for example, in 1 Corinthians 12, verse 10, where it says, to another miraculous powers, to another prophecy, to another distinguishing between the spirits. And then Paul lists some other gifts. So he talks about the distinguishing between spirits. And in 1 John 4, John gets more specific, where he says, dear friends, do not believe every spirit, but test the spirits to see whether they are from God, because many false prophets have gone out into the world. And then in verse 2 he says, this is how you can recognize the Spirit of God. Every spirit that acknowledges that Jesus Christ has come in the flesh is from God. But every spirit that does not acknowledge that Jesus is not from God. This is the spirit of the Antichrist, which you have heard is coming and even now is already in the world. And then in verse 4 he says, you, dear children, are from God and have overcome them, because the one in you is greater than the one who is in the world. And now it gets interesting. In verse 5 he says, they are from the world and therefore speak from the viewpoint of the world, and the world listens to them. We are from God, and whoever knows God listens to us, but whoever is not from God does not listen to us. This is how we recognize the spirit of truth and the spirit of falsehood. So what I think it's interesting is that John he talks here about the viewpoint of the world, and basically that's what we achieve in science sometimes is an interpretation of the data, which is a viewpoint. It's just first of a neutral viewpoint, but most of the interpretations of science are from the world, and that's why most interpretations of science are such a viewpoint of the world. And I think one should notice that the data itself is kind of neutral. I mentioned the bias that can come in there, but it usually it should be, or in a perfect way, it would be completely neutral, and there would be the viewpoint of the world, and of course there also is the viewpoint of God. And I think by this gift of discernment that the Bible talks about, we can really get discernment of how the data is to be interpreted in the correct in the right way. We don't even need to have this scientifically put out in a special way, but we can discern in the spirit which response to the scientific data is the right one. And especially what I missed to say is, if you don't have this discernment of the spirits, you can also have this, or what many people then do is they act according to their beliefs. So if the trust the science is also oftentimes that people act according to what they believe to be true and call it science because they base their opinion on what to do so loosely on science. But what the approach is still not wrong to say, okay, these values, these things that we have that we believe, let's look what they tell us, and when we don't have the scientific data to know much about what scientifically might be the right answer. And even if we need to interpret the scientific data, we often interpret it from what we believe and which values we hold. So this might in either case be the right answer. But more than that, I think as Christians we should really practice this gift of discernment of the spirits to discern what is from the world and what is really God saying, what is really the thing that God tells us. And so my recommendation in all this is to really learn how to discern the spirits. And it's helpful, I think, to also learn a little bit about science, about how to interpret scientific data, because the spirit can then also use this to help us to discern between what the science really says, what how sure we can be of these statements, and if we can trust in it, or which response we should take to these data. And this finally brings us to maybe the hard question behind this, which regards our personal decisions. Should I get vaccinated or should I not get vaccinated? This is often the question right now behind all those trust the science statements. And my recommendation here is, don't listen to the viewpoints of the world if they are pro-vaccination or even anti-vaccination. So don't listen to either of them if they are coming from the world. So use this, or try to use this gift of discernment, this of discerning of the spirits. And I recommend kind of studying the scientific data, and then in discernment of the spirit, ask the Holy Spirit which is the right decision for you, which one you should take. And I think if you get vaccinated, there is no sin in that. If you don't get vaccinated, there is no sin in that. I think Christian scholars have agreed upon vaccinations being up to the liberty of each believer. So you don't need to feel condemned if you take either decision. But also it's important, I think, to know that God can protect you either way. So he can protect you if from maybe adverse effects of a vaccination, or he can protect you from the virus. I think it's important, however, to discern the spirits in this, to know what the science is saying, and also to know how to interpret this, and also to have the discernments of the spirits in which is the right course of action for you individually. Also, it might be just, as always, be a good idea to consult with your doctor and people you trust. And especially if you don't have a scientific background, then it might be wise to consult with somebody who has a scientific background, but who is also somebody you would trust, and you would know that he is really recommending you the right thing to do, or what in your personal situation will be the right thing to do. But that's just some points about this I wanted to make. I think it's best if you have peace about the decision you are going to take. If you can say that you have really this peace that is above all understanding with the decision you choose, I think that cannot be really the wrong thing to do. So, in conclusion, we can say that the statement, trust the science, really does not make any sense, because science itself trusts on you to not to be skeptic of the data, and to be skeptic of the especially skeptic of the interpretation of the data. So science is the process of finding new things out, and this requires doubting the status quo. And so, in conclusion, we can say that the statement does not really make sense, and that it needs the right discernment to get the right responses out of the data that we are presented with in science. So I hope this could help you and give answers to questions about science, especially science in today's world. Of course, this can be not only applied to our current pandemic, it can be applied to what to do about climate change. It can be applied to all the other kinds. It can be applied to what should a Christian think about theory of evolution, and so on. It could be applied to almost every scientific topic. And if you want to find out more, then I recommend you to subscribe to this podcast. Give a 5-star review if you are listening on Apple Podcasts. This just helps the algorithms to show this podcast to an even broader audience. And so I recommend you to do that. And you can, on my webpage, sci-faith.de/en, you find the English part of the webpage. There are also some blog posts, which also are podcast episodes that you can listen after this one. And so just check it out and get yourself acquainted to Sci-Faith. And as I mentioned, I have written a book about this topic of science and faith and how they can work together. And this book right now is only available in German, unfortunately. But if you are interested in having this as a version in English, then you can just write me in the contact formula and just spread the podcast to your friends. So if there are a lot of people who are really interested in reading this book in English, I will try my best to translate it or get it translated. So if you have interest in that, then just let me know. If you also have other questions that you would like to be answered on this podcast, then just you can also write me using the contact formula on my webpage, and then I will also do that. So I hope you have enjoyed this podcast episode, and in the next weeks I will also produce more content regarding topics or similar topics. Also, we will look into what I did not mention right there, but the scientific method, as I believe, has come about from many Christian philosophers or many Christian scientists. And I think there's a connection between the scientific method being created and the Christian faith of those who created it. And this is pretty interesting, and it kind of shows that science and faith are not so far apart, but rather that the faith had a great impact on science becoming so effective as it is today. So stay tuned for that, and until next time.